Local Aboriginal land councils were first established under the Aboriginal Land Rights Act of 1983 to assist Aboriginal communities at a local level. Our client is Illawarra Local Aboriginal Land Council, who are represented by Jade Kennedy, who came and spoke to us in week 1 of ENGG 105. The Illawarra Local Aboriginal Lands Council is located in the South Coast region in the Illawarra Basin, circled here in red. Geographically, our client resides in the Darawal country, which is in southeast New South Wales and spreads roughly from La Perouse in the north, Jervis Bay in the south, and as far west as Camden. The traditional owners of the land are the Wadi Wadi people. Our client, the Illawarra Aboriginal Land Council, does a lot of things, including social housing, cultural heritage, employment, training, and advocacy for Aboriginal rights. Our client values are first reducing the reliance of major infrastructure, which in turn reduces the impact that it has on this land. This is known as caring for country. Second is supporting self-determination, enabling financial independence through development focused on enabling entrepreneurship and empowerment. And lastly, supporting community well-being, which comes in the form of physical, mental, cultural, and social. Our client's approach is holistic, cyclic, dependent on relationships and the connections between all things, making sure everything is equal, land is sacred, and there is minimum harm to all involved. Our goal is to create an engineering solution for the waste that occurs in the Illawarra region, with an innovative and thoughtful design based on Aboriginal perspectives of country, kinship, culture, journey, and connectedness. We will demonstrate our clients' values and approaches throughout this presentation.
Waste is an Australian-wide product with approximately 67 million tonnes of waste ending up in landfill each year, with the majority of this waste being masonry, metal, and timber. For this project, the ash waste stream was a focal point as fly ash material was implemented into the concrete mixture for use in roads, thus furthering the life cycle and reducing the environmental impacts of fly ash. This material is a byproduct of burning coal for electricity, which is Australia's third largest waste stream, producing 12.3 megatons of waste each year. Fly ash has a profound negative effect on the environment as it consists of high level of heavy metals, which can contaminate local environments. Although the amount of ash produced per annum has decreased over the last decade, and recycling initiatives are in place, there still is a dire need to further reduce the amount of fly ash in landfill, thus highlighting that our fly ash concrete product has met a specific need both socially and environmentally.
Fly ash is a large contributor to waste in Australia. Thus, this project seeks to use this waste stream in order to develop a product of beneficial impact to communities and the nation. It was found that as a fine powder and combined with water and calcium hydroxide, fly ash would form a cement. With this knowledge, our project seeks to implement fly ash into concrete in order to be incorporated in roadways within Australia. In this way, we seek to increase the efficiency, safety, strength, durability, and economic sustainability of our roads. Typically, Australian roads are made from Portland cement, of which fly ash cement has similar properties, however it also has various advantages over this traditional cement. This fly ash cement has two major components, the hydrated silicate and the calcium oxide, which acts as a filler for the mixture. The proportion of these elements within the cement is of benefit as it positively contributes to the cement's strength. Furthermore, as fly ash consists of lighter and smaller particles, this positively impacts the final cement's workability, cohesiveness, and finish. Due to this contribution to the overall quality of the concrete, this provides an economic benefit as road maintenance and repair is lowered.
In order to further validate our product, we performed testing, which aimed to determine the ideal ratio of fly ash to Portland cement for our mixture. In order to best replicate the concrete which would be used for road construction, the mixture contained a coarse aggregate, a fine aggregate, water, and our cement mixture. We created 10 samples which ranged from 100% fly ash to 100% Portland cement by their mass. Additionally, they also contained 800 grams of the gravel, 400 grams of sand, 200 grams of water, and 400 grams of the cement mixture. Once dried, these slabs were then subjected to a strength test, where they were loaded with a hanging bucket at the centre and were slowly filled with water. This was performed until the concrete broke. As shown in this graph, the results suggested that fly ash does not in fact increase the strength of concrete, contradicting all prior reading, and so further research was undertaken to determine the cause. It was discovered that fly ash cement mixtures actually require less water. In order to reduce contributing variables though, the initial experiment had set the water amount as a constant, which in this case may have negatively affected the strength of the final concrete. However, this did provide insight into the behaviour of fly ash, and so could easily be rectified with less water in the concrete mixture. This actually provides another positive environmental impact.
The cost analysis section encompasses the financial situation of the product throughout the cradle to grave process. The cost of the road construction is influenced by many factors, which can include, but are not limited to, length of road, number of lanes, the type of road, for example, highway or residential, and the time frame of the project. The cost analysis further describes and analyzes other factors such as labour, material, and equipment costs to give the client a clear idea of the finances involved in producing the fly ash concrete product. For example, take into consideration the staffing costs for operating a plant where, according to pay scale, the average salary of a construction labourer is $39,882. Additionally, other estimates were made in regards to acquiring land for the plant to operate and were budgeted at $200,000 to $2 million, according to researching current properties for sale on Real Commercial, thus conveying the certain aspects that will need to be financially addressed in order to facilitate, produce, and operate the fly ash concrete product. In a 2018 report prepared by the Australian government, which analysed 32 motorways, they found that the median cost to construct a road, including all costs of labour and materials, to be $55 million, with a median of 24 kilometres of lanes. Therefore, it is critical to financially evaluate the product in order to determine its feasibility and the budget.
In order to commence the fly ash project, it seeks to initiate a relationship between the coal-fired power plants and the local and Australian governments. In this way, it incorporates this waste into the concrete used for public roadways. Disposal of the coal ash is currently both a logistical and economic issue for power plants and governments alike, making this a solution that would prove beneficial for both parties. It would allow the power stations to have a sustainable fly ash disposal method, whilst the government would reduce cost of road materials and maintenance, as well as increase road quality.
Australia has been carefully maintained and cared for by our first people through their values of caring for country, self-determination, and supporting community well-being. Fly ash concrete is an innovative and creative solution which keeps toxic ash from polluting the environment, caring for our country. It also addresses the need for sustainable infrastructure as the country continues to grow, keeping our communities connected and supporting their well-being. Finally, it has the potential to create more local jobs, encouraging self-determination and community-led action. As Australia grows in population, the need to develop sustainable infrastructure has become ever more important. This, in addition to a constant depletion of our finite natural resources, requires the development of a creative and innovative solution. In addition to this, our client, the Illawarra Local Aboriginal Land Council, brought to our attention the massive waste crisis which is facing Australia. Fly ash concrete sought to reimagine and reform current methods, whilst considering Aboriginal perspectives and teachings which have spanned over 60,000 years. In using this improved concrete, the Illawarra Local Aboriginal Land Council would be helping to connect communities sustainably, paving the way to a better future.